Hi guys, my name is Jahanara and I'll be going over lab 1 on charged tapes. So in this lab, we were to prepare pieces of scotch tape interacting with each other and observe their interaction. So when they interact and then quickly ripped apart, a charge is created between the two pieces. In this experiment, our goal was to understand the concept of electric charges and forces by determining these charges between the tapes. So the fundamental equations used in this experiment were Newton's second law, along with the equation for electric field of a point charge, as well as the Coulomb's law. So these are some of the results that I found out. We'll be going more in depth about the results later on, but I found out the charge of the tape, the ratio of excess electrons, the number of electrons on the tape. So before we start the observations and the scenarios, we have to go over some assumptions. So both tapes have equal charges, both tapes treated as point charges are equally distributed, and we ignore all air resistance along with all forces besides gravity and electric force are also negligible. So the experimental procedure and observations, we start off with determining the U-tape's charge. So the first step was to set a base on a flat surface, which I used as a desk. And then we take a piece of tape of the same length and put a fold at the edge, which becomes our U-tape. And in order to determine the charge of the U-tape, we put it next to a negatively charged particle plastic pen and also observe the interactions between them. And for the second part of the experiment, we took one U-tape between two objects. For me, it was a book, and we placed another one underneath. And we used the distance between the first tape and the second tape and use it later on for a computational model. So these are some of the length, mass, and distance I found out. For calculations, we did the gravitational force, the magnitude of gravitational force. And then we also found out the charge on tape, which we used the net force in y direction to find out the charge on tape. We also determined the number of electrons on tape, which is also the excess electrons, which is basically the charge calculated divided by charge on one electron. For the number of atoms, we took the area of tape and divided by area of atom. And lastly, we found out the ratio of electrons to atoms, which is basically the number of electrons we found out divided by the total atoms, which for me was 3.88 e to the 10th per one atom. This is the computational model. The same data was used for the computational model in terms of the length, mass, and distance. The same equations were also used that we went over in the introduction. So here we can see to the right, the red space or the red sphere is tape A. The blue sphere is tape B. The green arrow is that is pointing down is the gravitational force, and the yellow arrow that is pointing upward is the electric field. So before we close off, we need to answer these questions. What if electrons had positive charge and protons had negative charge? What would change about the observations we made, and along with the charged objects? Essentially, there would be no change because it would be vice versa, but the fundamentals would stay the same. This is because both tapes would end up having the same charge and would still repel each other. In terms of other objects, the principle stays the same, like I said. Therefore, they would attract or repel each other at the same rate. So the next question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Obviously, it is important to handle them as little as possible because the charged objects have electron deficiency, and too much contact can lead to a decrease in reaction between the U-tape and the other charged objects. So this would lead to poor and inaccurate data entry for our experiment. Thank you so much for your time, and I hope you have a great one. Thank you.